Welcome to Startup TV Boston. I'm Michael McCarthy, and we're coming to you live from Beijing, China. And I'd like to welcome my guests from the Open Science Organization, Kirk and Gajendra. Gentlemen, welcome to the show.
Thank you.
Thank you.
So for those of you who are not familiar with Startup TV Boston, I'm the instructor for Harvard's Entrepreneurship and Innovation course, and our final exam is to do a startup. At the end of every semester, we always have some students that come to me and say, where do we go next? Where do we go from here? How do we get funding? So I started Startup TV Boston so that I could put some of the students on TV shows. They get broadcast a few times in Boston Cable, and then they go on YouTube. And from YouTube, they send the TV show around the world to venture capitalists and to VC firms getting funding. We've actually had some startups get funding. We had another startup, a teenager from MIT, where I was working for LaunchX, a high school summer program. He got into Stanford. We've had some other people get their products into large retailers like Walmart. So, gentlemen, we actually met several months ago at the IBM Blockchain Startup. And I'd like you to share with me a little bit about what is your startup idea and where did that idea come from?
Startup idea is about how we can develop a decentralized platform for everything that happens, any activity for scientific research, starting from the funding to ending in the scientific publishing, because we saw there are like so many middlemen introducing inefficiencies in the system. And we think that Internet 3 technologies such as blockchain can actually solve this problem and make society a better place.
Excellent. So for most of our studio audience, they're not technically oriented and they're not familiar with blockchain. So that everyone can start off on equal footing, could you share with us a very simple definition of what is blockchain?
Blockchain is I would go with, instead of software, it's a blockchain is a type of database that gives a layer of trust, just like internet is a concept. It's a set of protocols that allows people from all around the world to talk to each other. Just like a blockchain adds a layer of trust, so that you don't have to depend, like you don't have to say that there might be some, again, I should not be using double spending. Anyway, blockchain is a layer of trust. It's a software that gives you a layer of trust so that you can depend on it.
Excellent. And Kirk, a question for you. What problem is your startup solving? In just the most simple terms, what problem is it solving?
I think the simplest terms is getting research more accessible to both the researcher and the lay public, and just having a trustless system in order for both sides to access it freely and openly to help enable research and push it forward.
Okay, so I'm actually interested in academic research, and I'm not a scientist. I'm just generally interested in reading people's abstracts, which is the little short summary, because I don't want to read the whole thing. And what I have found is that there are a lot of academic journals. I go to Google Scholar. So when I go to Google, I just type in Google Scholar, and then I type in what I'm looking for an academic journal. And I find that a lot of academic journals, you have to pay for. And I tend to look at the free ones. So I actually don't have access to all the academic journals that are out there unless I log into my Harvard account, then I get into the Harvard libraries, and most of it's free through that. But I know about Google Scholar, and now the viewing public knows about it. How would you be, with your startup, allowing people to get more access to academic research?
So one big way is that we'd have a repository for researchers to place their research. Instead of going through a publisher and having them have complete control over their published research, it would be published to the platform in an open manner, and then that way anybody and everybody who have access to that platform, which in our case would be anybody who's interested in scientific research, would have free access to it whenever and however they'd like.
I see. So the problem you're solving, correct me if I'm wrong, is that let's say I'm a scientist and I have some really interesting research that I want to share with the world, but I can't get anyone to read it because the publishers aren't interested in it, but I think the public might be. And I can get rid of the publisher and go directly to the public and say, hey, I have a really cool idea. I would like you to hear about it. And I don't have to have a publisher agree or disagree with that. I'll let the public make up their own mind. Is that what you're doing?
Yes, that would be exactly what we're doing. But we don't want to throw out a very important part, which is peer review. And that's one thing that publishers do is match up for peer review. So we want to keep that as part of our platform. So there's a necessary part that the publishers do that hopefully our platform can absorb, and then also at the same time make it freely available that publishers may not do. So just having a nice system for keeping the good parts and opening it up to everyone, no matter what.
And Kirk, you're part of MIT's Broad Institute, is that correct?
Yes.
Could you share with us what you do at the Broad Institute, and also define for the audience, what is peer review and why is it important to keep it?
Sure. So I'm a postdoc at the Broad Institute. So what that means is I'm post my graduate work. So I just finished my PhD back in May, and I started, previous May 2017. Mm-hmm. And what I do is research here. So I'm focusing on genomic research, and peer review is fairly important scientific research because you're very focused on your topic of research, and you want to make sure what you're saying and what you're coming up with is valid and is also checked by the community. So peer review happens, you have peers have similar or expert knowledge in the same area, and they can check your work, and they can also make sure, you're thinking about this wrong, or maybe you need this kind of thing, or maybe you need to check out this experiment here. And they're kind of guiding you, and then also making sure that not just false information is getting put out there. It's all good information, and then moving science forward in a positive direction for everyone to use and enable better research in the future.
I see. So peer review is sort of like a quality control or a self-auditing function within the organization. Would that be a good way to summarize that?
Yes, very good way.
Okay, beautiful. Well, I'm really excited to see your pitch. I know you have a pitch deck, and I'd like to invite you to share your screen now so that me and the rest of the studio audience, we can take a look at your pitch and get a deeper dive into what you're doing.
Sure. Can you see it?
Yes.
Great. So like we said, we're here to talk to you about the Open Science Organization, which we're proposing as a nonprofit community driven by the researchers, the public, and any interested stakeholder that would want to drive science forward in an open and inclusive manner. And what this organization would do is help develop and manage the whole scientific process through blockchain technology. So an open and distributed and trustless ledger. So putting trust into the system from all the way from funding, from research, and to the publication process. So why is this important, and some of the problem areas here? So there's different problems, and this is not all inclusive. This is just some examples for funding. It can be very hyper competitive. So there's less and less funding each year. So budgets are being cut for scientific research, and more PhDs are graduating each year, so they're doing more and more research, so it's more people with less funding. And then there's also funding biases, and what do we mean by that? We mean that there's certain hot topics or certain areas of focus that might get more funding, so that might drive research in that direction and might kind of leave out some other really good areas that might be necessary for research but don't have the funding at the time, so can't be done. For the research itself, irreproducible research can be an issue. So that means that there's been studies done where 50% of the research is not reproducible by independent labs, meaning outside labs cannot pick up a paper and reproduce the research in it. So that could mean that the research was not done properly. There's not enough information there to make sure it's being done right and can be used for future research. And there's also what we call a lack of cross-pollination. So there's a lot of collaboration within a domain. So like I'm in genomics, we talk a lot within genomics, but outside of that, so if I go over to machine learning and the computer science, there's not a lot of talk in between genomics and machine learning. So it'd be nice to have a lot of crossover there to help us both push forward. And then with publications, we've talked about some of the issues, but it could be very slow. It could be very closed. So you don't know what peer review could be done. You don't know how some of the different edits were being made in the process. You just kind of see the final result. And it could be very expensive, where the journals cost money to publish a paper, and it also costs money to access the paper. So the taxpayers and everybody in the public that's paying for research is actually almost paying 3 times: one to do the research, one to publish the research, and another time to actually access the research if they're very interested, or if they can't find it for free on Google Scholar. The current system, like we talked about a little bit, but just to kind of go over some more, the data collection part, that's where it introduces some irreproducibility, where you don't know how the data was collected. And that's really important for another lab to collect similar data so they can do similar research, or what was done to that data in order to produce figures or charts into a manuscript or a publication that a researcher would read. And then the results. So the results actually chosen to be into a publication. So they might be they look at the best results and they say, these are the most significant findings. So we're going to put that in the publication to put our best foot forward, which is great. But there's a lot of negative or non-results that are left out. And that could mean, errors to avoid for other researchers, or best practices that you miss out on because they are not included into the publication, which me as an outsider would miss out on, and then I could be running into some of those same pitfalls. Mm-hmm. And then the review process, it could be very slow, like we talked about, and the editor and publishers more act as a match service for expert domain knowledge, but the professors doing the actual reviewing are doing it for free. So the publishers are making a lot of money, but the reviewers are not, and the scientists publishing are not. So the publishers are kind of acting as a barrier, and we're hoping to replace that part with the trust of the blockchain in order to help alleviate some of the middlemen and speed up the process. And then, like I said, the dissemination, the publication actually is expensive as well. So it could cost anywhere from $2,000 to $10,000 for one paper to be published. And that could take up to another 4 months in order for it to be accepted and then actually published into the system. So all of this could be alleviated by introducing a trustless system like a blockchain and have it distributed out to everyone in the system to use, like we're proposing with Open Science Organization.
It's Kirk already said how current publishing systems are act as a middleman and creating inefficiencies due to that. Here in the right figure, you can see the general stack of what happens during the scientific review and publishing. The first part is the matchmaking between the manuscript and the expert peer reviewers. And other two parts that are red is just formatting the publication and hosting the file. But the significant part that creates the most value in the system is the peer review by the experts or the fellow researchers. And it's actually ironically done by free by the researchers, and all the profits is taken by the publishing houses. And what we propose is to replace this publishing housing system or this journal system by a decentralized a decentralized platform that's made from modular components of Internet 3 components. And that decentralized platform would be built and managed by a non-profit community of researchers that we call Open Science Organization, or OSO. And that OSO platform will manage all research activities starting from funding to publishing. If journal systems of the publishing houses were compared to the telephone operators back in the days, Open Science Organization would be a decentralized future, but much better than the current system. Let's talk briefly about the technical stack of the OSO platform. As a non-profit community, Open Science organization will first build the basic fundamental technical architecture for the decentralized platform. And there are like four main pillars. And there are four projects dependent on that we are working on parallel, which we some of them will talk briefly later. Here, four of the main pillars are identity of the researchers, idea of the researchers, and how we review the idea in a decentralized manner, and how do we store those ideas. This is just a general design. We are still working on it. But the general idea is that we first, as a also we build the fundamental technical platform for scientific research, and on top of that, it's the users or the scientific researchers who it's up to them how they want to use the system. For example, on top of OSO network or OSO platform, they can establish their own sub-networks, maybe depending upon their area of interest. For just like there is a subreddit according to the interest, there is like a Reddit for nature, Reddit for cryptocurrency, Reddit for machine learning. Just like there can be sub-networks for genomics, computer science, and these sub-networks are, by the way, not mutually exclusive. Their interaction between them is frictionless, and even within the sub-networks, there can be other sub-networks, and within any sub-network, there can be channel, just like a journal, like where one channel can be, let's say, a breakthrough findings in genomics. Another channel might be for computational methods for genomics. And one channel can actually share like multiple networks or multiple sub-networks. It's up to the researchers how they want to use the system. Let me briefly talk about the identity problem that we are tackling right now. Currently, identity of our identity of us or any researcher is splitted, or like it's in different silos of central entities. There's like, we have like Google Scholar ID, we have ResearchGate ID, we have ORCID, like there are like 5 other different things. And it's very difficult, especially if somebody is from China and have like shares a same name. And there are like have been lots of cases when people using other people's name and using their credentials to get a job or doing other things. And we propose this unique researcher identity. It's a global persistent cryptography-based identity that maps the physical identity of a researcher to an online identity, in this case URI, and that connects with the OSO platform. We are actively working on this project, and we already have a proof of concept of this project, and we are actually in collaboration. We are talking, I wouldn't say the word collaboration, we are in talk with few universities kind of to test this idea. Another novel feature of OSO is a generalized idea protocol. Here, idea means anything that has like new knowledge. It can be a publication that we are familiar with, or it can be a website, it can be a piece of software, it can be a blog, or it can be a blockchain. It can be anything that has like new knowledge. Since we are more familiar with the concept of the publication, let me go with that first. Let's say idea I0. So there's a title, abstract, content, and it cites idea I1, I2, and I3. So that means it cites idea 1, 2, and 3. Means it borrows the idea from 1, 2, and 3. So the idea flow is from left to right. That's in the blue, and it's weighted accordingly. And the novel thing about idea protocol is there is this value flow that flows backwards. That's from right to left in orange color. Let's say, for example, idea I0 manages to create a value, maybe through a patent, maybe through a product or gifts or donation, or like somebody cites the publication, then that a portion of that value created flows back through, there is some back propagation Of course, there is some absorption coefficient that's decided by the users, but this concept of the value flow and idea flow really solves this problem of this broken architecture in the scientific research system, where like we fight for the funding, and using that funding we do research and we have some results. And what happens to that results is just we have like 4-page, 5-page publication, that is. But using that results, people create millions and billions of dollars of products and values, and that never flows back directly to the funding pipeline. But now with this protocol, if the value gets created in front of patents, products, or any other form, it can flow back directly to the scientific funding, and that kind of partially solves all this hyper competitive funding scenario currently we have right now. Maybe Kark wants to do that.
Sure. So this is a general concept for peer review. So down here at the bottom left, very bottom node would be the original idea. And you can see every time you go up an arrow, it gets a new edit or a new review, or more gets tacked onto it by the researcher. And then a new researcher or peer review comes along and says, hey, I got a great idea. And they follow this branch and add their idea, and it can be put back onto the main idea then. So they can update that new idea, and that researcher then can get credit for that update. And you can see this could happen at the very beginning, or it could happen in the middle, and these ideas can be updated throughout. And all of this can be tracked nicely, and each researcher can get the credit they deserve for what they contribute to the new ideas. And sometimes this is hard to do in the current system. And having a system like this could have a more finer detail of saying this researcher contributed this exact idea to this part of the project.
Evolution of OS. So it started during my PhD, like the frustration with the whole process. I saw how much time it takes to publish a publication, how much you have to pay to publish a publication. And I have seen like professors spending all the time fighting for the grants, and like with that time they could be actually doing some novel research. And so I had just moved to Boston last year, and it was, I was like kind of writing my thesis and in the process of getting the news up at Phillips here, but I didn't have a work from it. So I had this 2 or 3 weeks gap period, and it was really cold in Boston in February. And at that time I started writing a white paper, and then I published it in August 2017, and Avinash, Vikrant, and Rob, they joined around that time. And it seems that it's not unnatural, like there are other people who are like equally frustrated with the system and equally motivated, just like me. And there was Keith Smith. He had proposed this system called Aristotle 0x. It's a decentralized journal system based on a district 0x. It's a decentralized market protocol. And Keith Smith and we met each other online, and then we had email conversation for a few weeks, and then he later decided to join also. Now he's leading the identity project. And then I met Kark in Boston. He was equally frustrated and more passionate than me, and he was working on this decentralized GitHub for scientific publication, a project named PubHub. And then he joined also, and then lots of people like Norman, Kevin, Ken, Neha, Susan, Andrew, Eric, Sandeep, they joined us. Recently, Joe from RIT, he joined as a member. And most recently, Professor Zhang Liu from University of British Columbia, he emailed me saying, oh, I really like your white paper. I'm really excited. I want to contribute to this project, including my students. So we are collaborating with him in our unique researcher identity project. So now we are a strong 18 group of professors, scientists, and engineers. We have team across US, Canada, and Netherlands. And we have like lots of people from different universities, especially in the United States, contacting us, saying that they want to start groups across universities. And yeah, at this time, we're really moving forward with the network growth.
Great. Well, thank you for your presentation. If you guys unshare the screen, we'll have about 3 minutes left for some Q&A. I think it's a really cool idea. My first question is, you want to have it as a nonprofit, and I understand that. What is going to be the incentive for someone to do a peer review? What's going to get a really highly qualified person to spend the time to review someone's paper?
Here there are like two incentives. First, it depends upon if in that sub networks, if there's a financial reward, let's say, in terms of also tokens of our system. That's one. Second is reputation score. Because it's always persistent, they can use that reputation score as for their career growth or to on funding. It's just like how do we use like number of citations as a proxy measure of our career growth.
Sure. And Kirk, in our final 3 minutes, I'd like to just dive a little bit deeper on the peer review. What are your thoughts about somehow incentivizing or paying for an objective review? Let's say that you wrote a really great paper and maybe there's a well-known researcher that you would love to peer review. Is there an objective, unbiased way where you could compensate that person to review your paper for you?
You would like to think so. It would be a really tough scenario, but when there's a financial incentive involved, there's always that line you have to tell, is this person doing it because they're paid for it and they're going to be honest and objective? And I think that's where a trustless system like a blockchain could come in, because his reputation's on the line too. It's not just him getting money. So having a distributed ledger like the blockchain and having it open and available for everyone to access, they can see how much he got paid, what kind of review he made, when he did it, and so forth. So like all of that will be available to the public. So he's not just getting paid and running off with the money. He can actually staking his reputation on the line as well. And I think that would be the answer. And I think that's why a blockchain would be so important and why it's so important to have it open so everyone can see who's doing what and who's involved in what.
Great. And in our last minute of the show, Kirk, can you tell us where are you now? What is the next step in having you guys see this as being a reality? What's the next step for you?
Yeah, we're really excited, and we have 4 projects like Gajendra was saying that we're going in parallel, and we're just hoping to keep growing our network and keep getting the word out there and getting as many people participating. Like I said, we were an open science organization, a network, and it's a platform, and the more researchers and the more people involved, the better. So if you're very interested, please contact us. Please get involved. If you can Google open science and open science organization, you'll see us right away. And the more we grow, the better off we'll be, and the more people involved, it'll keep growing and growing, and then that'll how we can accomplish this.
Great. And I have a friend who does peer reviews. I'd like to put you in touch with him so that he could give you his feedback, because he's actually going to be a customer. And I want to thank you guys for your time. I would love to have you back here in 12 months so that we can do a check-in and see how you're doing. And again, thank you so much. I think you guys are doing a great job of cutting out the middleman who's not really adding a lot of value, and maybe you'll get rid of some friction. And it's another opportunity for blockchain to help out the consumer, get rid of the middleman, and make things go faster and better. So thank you for your unique ideas, and I wish you all the best.
Thank you very much.
Thanks for hosting this.
And to the world, Beijing, China, Cambridge, Massachusetts, and MIT's Broad Institute, everyone, I wish you well, and we will see you on our next show. Take care.